What fuels your passion? Are you amazed by the technologies emerging from every corner of the globe? From self-driving cars and humanoid robots to artificial intelligence, IoT, and more? Do you dream of leaving your mark on this dynamic landscape of innovation? Then, it all comes down to one fundamental skill: coding, specifically coding in Python. Welcome to another exciting chapter in our beginner Python course. In this lesson, we'll unravel the secrets of dealing with bugs or errors in Python. Errors are a natural part of computer programming, and regardless of your experience level, you will encounter them in your code. Errors can manifest for various reasons, and as a skilled programmer, it is essential to anticipate and effectively handle errors, whether they are caused by user actions or programming mistakes. By doing so, you can create more robust and user-friendly programs in Python. Let's begin. Let's fire up our PyCharm code editor and create a new Python file called errorhandling.py and press enter. Now, let's write a simple Python code and intentionally omit an important detail. So we'll write print hello world and intentionally omit this detail. Let's run it. Run error handling, and oops, we have an error. Whenever you see this red message, it signifies an error in your program. This error message tells us where the error occurred in our program, in this case on line 1, the type of error we are dealing with, and what caused the error. So over here, we see that the open parenthesis was never closed. Also, this error is called a syntax error. In computer programming, we generally encounter 3 types of errors: syntax errors, logical errors, and runtime errors. Syntax errors occur when we violate the rules of the programming language. Just as any spoken language has its grammar rules, Python has its own set of rules for declaring variables, creating functions, and writing statements. When we break these rules, such as forgetting simple colons, proper indentation, or neglecting to close parentheses, then we encounter a syntax error. Now, to fix this error, let's simply add a closing parenthesis where we see this red mark, run it again, and voila! Hello world with no more syntax errors. Indeed, errors are a fundamental part of coding, and even experienced developers encounter them. Therefore, learning the skill of effectively handling errors is crucial to becoming a better programmer. Next, we have logical errors. Logical errors occur when there are no syntax mistakes, but they happen when the code doesn't produce a desired output or results in unintended consequences. For example, let's clear this code and write something new. We will start with declaring 2 variables. So, we have num1 equal to 10, num2 equal to 20. Next, let's find the average of these 2 numbers. So we write average equal to num1 plus num2 divided by 2. And then let's print the results. Let's run it. And the output is 20. This code contains no syntax errors, but the resulting answer is incorrect. The average of 10 and 20 should be 15 and not 20. So in this particular case, although there are no syntax errors, there is a logical problem with our approach. This type of error is known as a logical error, and it can be quite challenging to identify. Logical errors occur when we make simple mistakes, such as using subtraction instead of addition, or division instead of multiplication, and so on. So to fix this error, we need to use parentheses to calculate the addition first before the division, like this. Open parenthesis, close parenthesis, then the division. Let's run it again, and the average is now 15. Excellent. The third type of error we'll discuss is runtime errors. Runtime errors occur when the program is running and encounters unexpected issues that interrupt its normal execution. For instance, if a user is expected to input a number for a calculation, but instead inputs text, this can trigger a runtime error. Similarly, other issues like missing files or incompatible operations can also result in runtime errors. Let's try another example. Let's imagine that you have a bank balance and you wish to make a withdrawal. Let's create a simple program to demonstrate this. So, set initial bank balance. Then we'll say bank balance is equal to 100,000. Then ask the user to enter the withdrawal amount. Then we'll say withdrawal amount is equal to input, enter the amount to withdraw. And then let's calculate the current balance. So we'll say current balance equals bank balance minus withdrawal amount. And lastly, print f your current balance is curly braces current balance. Let's run the program. Enter 400, press enter, and suddenly we encounter an error on line 8. This is a type error, which is an example of a runtime error in Python. The error message reads, type error, unsupported operand types for subtraction, int and string. In simple terms, it means that you cannot subtract a string from an integer because it is not a valid operation. To rectify this issue, similar to what we've learned in previous lessons, we need to convert the input to an integer using the int function, like this. So we click here, type int, open parenthesis, click here and close parenthesis. Let's run the program again. Enter 400, press enter, and now we have the correct result. Your current balance is 99,600. Great job! No errors this time. However, if the user makes a mistake by entering wrong characters other than numbers, it can also result in a different type of runtime error. Let's give it a try. Let's run the program again, and instead of entering an amount to withdraw, let's type hello and press enter. And as expected, we encounter an error. This error is called value error. This too is considered a runtime error. Other common runtime errors in Python include name error, zero division error, that is when you try to divide a number by 0 when the program is running, index error, and more. So how can we address these bugs effectively? Yes, that's right. Errors are also referred to as bugs, and sometimes, with a more technical term, exceptions. Also, the process of finding and fixing bugs in a computer program is known as debugging. One easy way to debug effectively in Python is by using the try and except feature in Python. The try and except feature is powerful. It allows you to catch errors in your code and enables you to create user-friendly messages as responses to errors, or perform planned operations when an error occurs. Let's see it in action. We'll modify our code by clicking here and type try, colon, and indent all this code under the try, like this. And over here we type except, colon, enter, and then our user-friendly message, print invalid input. Please enter a valid number. The try block allows you to test a piece of code for errors. This means that any piece of code where you suspect or anticipate an error should be placed in the try block like this. Then, in the except block, you can provide a user-friendly response like this to handle the error if one occurs. So, in this example, the input statement and calculations are placed in the try block to watch out for any potential errors. And instead of having the red error messages, a more user-friendly message is provided in the except block if the anticipated error occurs. Let's run the program. Enter 400, press enter, and we have the correct calculation. Let's run it again. This time, I will intentionally enter the text hello and press enter. And notice, instead of the program crashing, we have a more user-friendly message telling us invalid input. Please enter a valid number. It's worth noting that while the except block can provide feedback for all errors found, it's best to specify the specific type of error you expect and write a more meaningful response for that error. For example, in this piece of code, the most likely error is a value error. So let's modify our code and include a more specific except block. We will click here and type value error. Let's run the program again. Enter 400 and press enter. And the program works well. Let's run it again. Enter hello, press enter. And we have a more specific and meaningful response. As a developer, if you anticipate another type of error, you can also raise an exception for that error as well. Like this, we can click here and raise another exception, except zero division error, print, you cannot divide by 0. And then at this time, you can use a generic except block at the end to catch all other errors, like this, except, colon, enter, print, an unexpected error occurred. Very good. However, in this code, we don't expect a zero division error. So let's remove that block. Excellent. Using the try and except feature this way is much better because it gives you the flexibility to provide an appropriate response for each type of error that occurs in your code. Someone may ask that as a beginner, how do I know the exact name of the error to raise an exception for? One solution could be that you anticipate the error, test your code for errors without the try and except feature, and identify the name of the error in the red error messages, and then you can implement the try and except feature for that specific error name. In future lessons, we will learn more about the try and except feature, including its else block and finally block. We will also delve into advanced error handling and debugging in Python. Before we conclude this lesson, I would like to clarify a few concepts in our code. In Python, you can separate long digits with underscores for easy readability, just like in our bank balance. Similarly, when printing out a long integer like our current balance, you can use F strings to separate every 3 digits with a comma. For example, in this F string, we will come to our current balance, click here, and enter colon and comma. Let's run the program. Enter amount to withdraw. We'll enter 400, press enter, and the output is nicely separated by commas. Beautiful. Lastly, it is important to adhere to the recommended naming convention for Python variables and functions. This convention suggests using lowercase letters for your variable names and functions, and separating multiple words with underscores. Following this convention enhances code readability and maintains consistency with the Python style guide. Great job on reaching this important milestone in your learning journey. You've come a long way and should be proud of your progress. I want to take a moment to congratulate you and encourage you to continue the fantastic work. With each step you take, you are getting closer to becoming a skilled Python developer. Keep expanding your knowledge, embrace new challenges, and never forget that every stride you make brings you closer to achieving your goals. If you encountered any errors, don't hesitate to share them in the comment section below. I'm here to assist you every step of the way. I hope you found this video helpful and learned something new. If you did, please hit the like button and consider subscribing to my channel for more coding videos like this. Thank you for watching, and I'll see you in the next video.